Now, the question here says the sketch shows the graph of the following function. We have fx being ax cubed plus bx squared minus 5x plus 50. That is the cubic function you see over there. Okay. We also have gx, which is the derivative of fx, which is px squared plus qx plus t, right? And that is the parabola, the negative parabola you also see. Now, we're given the x-intercept of f and the x-intercept of g. Okay. So the x-intercept of f is -5 and 2, and the x-intercept of g is -5 and -1/3. Now, before we get into the question and all this, one thing you always need to understand about the x-intercept of the derivative is actually the same thing as the x-coordinate of your turning point, right? So this is the same thing as the x-coordinate of the turning point of fx. So in case we might need it in question, always remember that. Okay, so let's get into the actual questions. The first one says we should find the value of a and b. Now, a and b was from the original equation of fx, which is, let's write that down. Okay, so that is the equation of fx. So the good thing is that we're given the x-intercepts, and the x-intercept is -5 and 2. So those coordinates are actually -5 and 0. And we also have 2 and 0. So since we have two unknowns, it would be recommended to substitute each of these coordinates into this our equation and see if you can get two equations and therefore doing simultaneous equations. So let's try this out. I want to substitute -5 and 0 into this. So substituting this is what you get. So dividing by 25, you're going to get so we can consider this our equation 1. Now we do the same thing, substituting 2 and 0 into this equation also. So this is what you get. We also can divide everything by 4 as a common factor. This will give you Now, before I move on, I actually noticed I made a mistake, right? So -5 cubed, I think that is -5 cubed. Yeah, I think it's -125. I wrote positive. So actually it affects our answer a little bit. This here should have been negative. This here should have been negative. And this here would be negative. There you go. Okay, so that's the only changes. Okay, so these are our two equations. This is equation 2, by the way. So with this, we can do simultaneous equation for this two equations to help us get our a and b. So we can rewrite equation 1 and equation 2. I'm thinking of rewriting equation 1 to be b is equals to, and equation 2 can also be written as this. Yeah, so I can equate both of them because they are both b. So this is what it's going to give me. So as you can see, a is equals to -1. Now to get our b, we just need to substitute this into any of the two equations. So let's say I substitute into this one here. I'm going to have negative. So our b would be -8, right? So our two answers are -1 and -8 for our values of a and b. And that's it. Now, the next question tells us to find PQT. PQT comes from the GX equation, right? So if I rewrite my fx how it should be, remember we got a as -1, so we're writing it as fx is equals to negative x cubed, -8x, -8x squared, -5x, then positive 50, right? So GX, since it is the derivative of fx, We understand deriving this here will give you negative 3x squared minus 16x minus 5. So therefore, our values for P is negative 3, values for Q is negative 16, and our T is negative 5. That's it. And the next question wants the coordinate of A. Coordinate of A, this one over here. Now remember what I said at the beginning of this question. I said that the x-intercept of your derivative is the same value as the x-turning point of your original equation. So if the x-intercept of this here is negative 1 over 3, this is my derivative, the x value for this turning point is actually negative 1 over 3. So to get the second coordinate of A, all I just need to do is substitute this negative 1 over 3 into the equation of fx. Okay, that's all I'm going to do. So I'm going to say, I'm going to say this, x of A is negative 1 over 3, right? So we substitute this into the fx formula. So the answer we get is 1372 over 27, okay? Negative 1 over 3, and this here will be 1372. 1372 over 27. Now we could also write it in terms of decimals, but instead I could also say it's negative 1 over 3 and 50,8. Now the next question wants us to get the coordinate of B. Let's look at B. B here is the turning point of your derivative of gx, right? So one useful information is that the x-coordinate of our turning point of our derivative is the same value as the x-coordinate of the point of inflection, right? So that's one way to look at it. We could also use functions, right? Whenever you have the x-intercepts, the two x-intercepts, and you're trying to get the turning point, you could use the midpoint formula, and it helps you figure out what that x value is, right? So that's what I'm going to use to answer this. There's multiple ways, but to me, I feel that that's the easiest way. So I could say negative 5 plus negative 1 over 3 divided by 2. What would I give you? Now to get the y coordinate, all we just need to do is substitute this x value back into the equation of gx. So putting this in our calculator. So this answer here is 49. The y of B is 49 over 3. Okay, so in decimals, we could say it is 16.3, right? So we can say our coordinate could be negative 8 over 3 and 16.3. Now for D2, it says determine the value for x for which f is concave down. So our cubic function is normally divided into two parts, and the midpoint of the division is our point of inflection, which is going to be somewhere around here. Now this part here is the concave up, and this part here is the concave down. If your concave down is after your point of inflection, we would say it is greater than our point of inflection. Now, since we said this before in the previous question, Our turning point here is the same value as our point of inflection, which is negative 8 over 3. And since, as we can see here, concave down is after the point of inflection, our answer will just be written as x is greater than negative 8 over 3. Yeah, and that is for concave down. That's all. For E, it says determine the value of GFX2. Basically, whatever you have in the bracket is what you replace with x. Now, this here is two things that is happening. The first thing is that we can look at the inside bracket, which is F2. Now, in the previous question, if you go back up, we notice that x to the 2 here, when x was 2 in your cubic function, it actually gives you 0, right? So it means that this part of the answer is F2 is just equals to 0. If you're not 100% sure, you can substitute 2 back into the equation of f and it will still give you 0. Now for the second part, which is this here, the answer, this whole thing now, is equals to 0. So I'm going to write G0, right? That is when x is 0. Let's go back up here again. We understand that when we have G here, right, when the x is 0, that would represent this point, yeah, which is our y-intercept. Our final answer will be negative 5 because that's the y-intercept of this value for G. And that is how you determine this whole thing over here. Okay. And for F, it asks us this. It says determine for which values of x would fx times gx be less than 0. Okay. So whenever you have a question like this, where they're asking you where two equations would be less than 0, what you need to look for is where one graph is above the x-axis and the other graph is below the x-axis at the same time. So we're looking at it above the x-axis. Look at F. F is above the x-axis. Yeah, as you can see here, from negative infinity, x is above the x-axis. Okay, and it's still above the x-axis there. But if you now look at G, you will see that at the same time while x was above the x-axis, G was below the x-axis at the same time until it gets to negative 5. So it would actually mean that our first answer can just be x is less than negative 5, right? Because anything before negative 5, f is positive and g is negative, okay? So now we now need to continue with this trend. We'll notice that G here continues we moves in here, moves into the positive, and is still positive, 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 until we get to this point again, where G goes into the negative. If you look at this point here, G is going into the negative, right? Okay. So F is still positive when it goes into the negative there, yeah? Okay. And it is still there, which is good, until it gets to 2, where now both of them now are negative. So from negative 1 over 3 to 2, the G would be negative and the F will be positive. Okay, so those will be our answers. So if I'm going to write them down here, I'm going to say my answers are x is less than negative 5, and I will also say or x is between negative 1 over 3 and 2. Yeah, we could also write it this way. Yeah, and that also works. That's it.